All right, I'm going to record the answers to some of those problems that we just did on Check Your Understanding, but I'll do that a little later. So right now we're just adding a few ideas before we start our assignment. And the first thing is a density curve. So we need to know what a density curve is. This information is part of your notes on Chapter 2, Day 2. So just add paper if you need to. The density curve is, suppose we have a histogram. So you recall what a histogram looks like. And suppose this histogram it's a histogram with a lot of data points described. So I'm just making one up. It turns out for large data sets, histograms that are very regular can be changed to a smooth curve. So I can take this and go like that and make a smooth curve out of it. When I do that, that's called a density curve. It does describe the data very well. And it's very close to the actual data. So we use it when there's a lot of data and the curve is regular, like this. So let's look at a density curve here. And let's say we have a density curve that has, I guess I can use the one that is up here. So I'm interested in the area under the density curve. So if I pick, say, this spot right here and I color in this amount, would you say that's about a third of the area under the density curve? I'd say about. So what if I added to it and went to here? That looked like half the area under the density curve. So in this line of thinking, what number corresponds to all the area under the density curve? And that's the number. So the area under the density curve, is 100%, which is the number 1. 100% is another way of saying 1. So the area under a density curve is 1, and the density curve is always positive. Always positive, because we can't really have, this is a frequency curve, so how can you have a -2 number of anything? So we've got to have a positive curve, and the area under the curve is 1. The only thing we have to finish with is where is the median and where is the mean on a density curve, and it works very much like what we've seen in the past. So say we have a symmetrical density curve, the median, which I do with the big M, and the mean is with the cursive looking Greekish M. They're at the same spot when we have a curve that is symmetrical like that. When we take the curve and skew it, though, we've had this before when we looked at histograms and so forth. Right here we have one that's skewed to the right, and we just review the fact that the median is pulled by the tail. So I don't know where exactly, but it's going to be here, and the mean is pulled by the tail, and the median is not pulled as much. So we should be pretty good with that idea. They add a point to this that I'm not sure I can explain. So maybe you can explain it to me. It's not, they said when you look for a graph, say it's not as easy as these two. Say you're looking at a graph, and the graph looks like this. Well, I'll start with the same one. I'll take this one. They said another way of looking at it, the median is where 50% of the area under the curve is on one side and 50% on the other. So when it's skewed this way, where would that be? You think about right there. Does it look like this is 50% and that's 50%? Maybe. it's very hard to determine. But for the median, capital M, you want 50% of the data here and 50% of the data here. Guess how you eyeball the mean? They said, and this is the part that I have trouble with, maybe it'll make better sense to you. He says, you want to imagine this as a plate, like a piece of wood or something. It's cut out like this. And the place where it will balance on the bottom. So if I had a balance here, and I had to balance it right on the tip of that arrow, that balance point part, that balance point would be the mean. Now to me, 50% on one side of the area, 50% on the other would be the balance point. Anyone get that? Do you think you get it?
No, I agree with you.
Right, so when we get to those, we'll have to fudge our way through. Any ideas? Why would the balance point be different than the 50% point? So I'm not sure.
You have greater numbers on the right.
Right? What?
You have greater numbers on the right. So
That's true, you do.
But it's
I think she's
That doesn't
got
make
it. I
sense
think she's
because
got
if
it, but
you
I
think
don't
the
know.
about
ones on the right way
It's
more.
like if it were
Yeah,
like
higher numbers way
Oh,
more.
Ah,
if it's like getting denser as it goes to the right.
Yeah.
I guess that's it.
So it's
then.
like lighter.
All right, I knew
That's
you guys
way
would
too
have
many
it.
like dimensions to
I
think
know,
about.
it's like-
All right, well, they're going to ask you to look at graphs and guesstimate where the 50% mark is,
We
and
already
where
kinda-
the median, where the balance point is, and I'm not going to be real picky about that. Okay? All right. The only other thing I need to say is when we have switched from a histogram to a density curve, we call the mean for a density curve, we call it this mu. And when we look at the standard deviation for a density curve, we're going to call it this sigma thing. You've seen that before. Do you remember what kind of situations we use these for? Because when it was a sample, we used x bar and s sub x for standard
Isn't this when you
deviation.
know the full population?
The full population, doesn't that does make sense with the density curve because we have 100% of the data. Once we go from a split bars to a mathematical curve, we definitely have a whole population. So we're going to go back for density curve. This is going to be the mean, and that's going to be the symbol for standard deviation. Let's look at our assignment. Brandon, we're on chapter 2, day 2, and the assignment is listed in that little box. You've already shown it to him a couple times, but you can show him again.
I didn't show this
Put
part
it
to
upside
him.
down. Put it upside down.
So it starts with 19 and ends with 38, some of those in between. So let's take out your paper and start your work. And that's all we're going to do today. I will come back and explain that one, check your understanding, but I'll do that later before I upload this video. See you later.